Hey all, we're working on the second challenge from the while loops unit, open-ended problems. This open-ended challenge is asking us to complete a function called next prime. This function takes a single parameter called num and returns the first prime number, which is larger than it. Note that this function will only take positive numbers. That's to say we don't need to deal with edge cases. Like we don't need to deal if someone gave it a string or a negative number or something along those lines. So anytime that I'm dealing with prime number stuff, it's really valuable to me to just use an is prime helper function. That's really what makes a lot of sense to me. And I'm going to need a few things here. The first thing that I'm going to need is I'm going to actually need to take care of some edge cases. I'm going to say if n is equal to 1, I'm just going to return false. And elif n is equal to 2, then we'll return true. And else we'll actually check if it's a prime number. We're going to iterate through some possible divisors for div in range of, and for the range of, let's go ahead and let's start at 2 and go with the integer or the floor of the square root of n. And if you're unsure of why we could stop there, think about this. Every divisor will be paired. So if we think about the number 16, the divisors are paired 1 and 16, 2 and 8, 4 and 4. So if I run my loop and I check for the largest, or if I'm checking for divisors, I don't need to go all the way up, right? Once I get to 2, I know that 2 is paired with something and it is a divisor of 16. The same thing goes with the number 4. So I know that 4 is paired with another 4. 4 times 4 is 16. Let's consider the number 25. This is a great example for this case. In the number 25, the number 1 is a divisor, but that doesn't really count for the checking for primeness. 2 is not, 3 is not, 4 is not, and 5 is a divisor. Now, after I've checked 5, there's no number larger than 5 that could be a divisor, because if it could be a divisor, it would have been paired with one of the numbers that was less than 5. So there is, in fact, no reason to check beyond the square root of a number, but we do have to go ahead and use the int version of that square root, because a lot of those square roots are going to be irrational or have large decimals, and the range function is always going to be looking for an integer. So I'll digress from that, and if we're going to say if our number n is evenly divisible by our divisor, that is the modulo is equal to 0, then we're going to go ahead and return a false, because we know there's a divisor and there's no need to continue checking. If we make it all the way through that loop, we've checked to the highest number that we need to, and we have not found a reason to return anything besides false. We haven't found a divisor up to the square root of that number, then we can automatically return true. We've checked for all of the possible divisors implicitly. So now we have to find the next prime. So the first thing I want to do is I want to use a counter, and I'm going to assign that counter at num plus 1. If we're looking for the next prime number, it only makes sense to start at 1 above the number that's given. And I'm going to do a flag here. I'm going to call this flag. I'm going to go ahead and say it's false. We'll just assume, and maybe we'll call this prime. It's a little more descriptive. Prime is equal to false. And I'll say while prime is equal to false, or while not prime in Python terms, then I want to continue on. What I always do when I'm writing for loops, I am just going to put my incrementer in right away, just so I don't forget to do it later on and accidentally end up with an infinite loop. Now, before I increment each time, I want to say if is prime, then I want to return something. So what is it that I'm checking if it's prime? The number that I'm incrementing each time, checking whether or not it's prime, is actually my counter. And when I have found that my counter is indeed prime, that is the thing that I'm going to want to return. So I can go ahead and run my test here, and I should be able to find, oh, I have a little error. Let me see what's going on here. Of course, we want to, for the case of 25, right, I would actually want to include that square root. So I always need to add a +1. I forgot to adjust my upper parameter in the range object to a +1. I give that an adjustment, and now my isPrime function works correctly, and my nextPrime function works correctly as well.